Hello student, welcome back. This is Bharat Khuman from Mechanical Engineering Department. Today we are going to discuss about the internal energy is a point function or property of the system. So student, without wasting of time, let's start today's topic. Student, as we know that first law of thermodynamics, it deals with the law of conservation of energy, where energy can't be created nor be destroyed, but it could be converted from one form of energy to another form of energy. So student, फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स के बारे में हम ऑलरेडी जानते हैं कि वो डील करता है किसके साथ, लॉ ऑफ कंजर्वेशन ऑफ एनर्जी के साथ, कि जहां पे हम एनर्जी को क्रिएट नहीं कर सकते और डिस्ट्रॉय भी नहीं कर सकते, बट यस वी कैन कन्वर्ट इट फ्रॉम वन फॉर्म टू अनदर फॉर्म, एक फॉर्म में से दूसरे फॉर्म में हम उसको लेके जा सकते हैं. वी कैन ऑल्सो से दैट एनर्जी इज ऑलवेज बी कंजर्व्ड. Heat and work, these two different forms of energy. If heat energy is provided to the system by the surrounding, then system may provide the work energy to the surrounding. And similarly, if work is being done upon the system, then system may deliver the energy in terms of heat to the surrounding. Hence, this is the basic concept of first law of thermodynamics. Now we will see here the detailed explanation behind the statement that energy as a property of the system and as a point function too. Let us assume that there is a one system which is undergoing a change of state from initial state 1 to another state 2 via following path A as shown in diagram. Here student, system is returning to its initial state, state 1 from state 2 via following path B. Here we can say that system is undergoing in a cycle 1 to 1 as displayed in the diagram. Student, here there is a total two state 1 and final state 2, and the process is 1A2 and 2B1. So cycle is 1A2B1. Let us recall the first law of thermodynamics for a system undergoing a change of state and apply for path A. Student, where system is changing its state from one state to another state 2. We have the following equation, that one is QA minus WA is equal to delta EA. It is for path A, where Q is heat, W is work and delta E is the stored energy or change in stored energy. Similarly, we will have a following equation when system is changing its state from state 2 to state 1 via following path B. So student, again देखें तो path B के लिए state 2 से state 1 पे जो सिस्टम है वो क्या हो रही है, रिटर्न हो रही है. तो हमें इक्वेशन जो मिलेगा वो ये मिलेगा, QB माइनस WB इज इक्वल टू डेल्टा EB. Again, QB represent heat, WB represent work and delta EB represent change in a stored energy. We have already seen that system is undergoing in a cycle 1 to 1 as displayed in the previous figure. Hence, we will use the concept of first law of thermodynamics for a system undergoing a cycle. Let us see the equation for system which constitutes a cycle 1 to 1, and we will have a following equation. So student, here the equation from first law of thermodynamics, that one is cyclic integration W is equal to cyclic integration of Q. Now simplify the equation. WA plus WB is equal to QA plus QB. It is the summation of work from path A and path B equal to summation of heat from path A and path B. Now simplify it, है ना. WB minus QB is equal to QA minus WA. So finally we gain the equation, that one is minus QP minus WB is equal to QA minus WA. So student, after all we achieve a final equation, that one is minus delta EB is equal to delta EA. Let us assume that system is returning from initial state 1 from initial state 2 via following the path C. In that case, we will go ahead similarly as we have gone above, and finally we will have a following equation, that one is minus delta EC is equal to delta EA. So student, now if we will look the end result for first case where system is returning to its initial state by following the path B, and of second case where system is returning to initial state by following path C, what we will secure here? That change in a system energy is the same in both cases, and it will not depend over the path followed by the system to return to its initial state. So student, therefore we can conclude that system energy will have some definite magnitude for each state of the system, and it will not depend over the path followed by the system. So student, hence energy will be considered as a point function and also a property of the system. So student, kindly attempt this mind twisted question and find a link in a description box. So student, आज का ये सेशन हम यहीं पे ख़त्म करेंगे. अपकमिंग लेक्चर के अंदर हम देखेंगे सेकेंड लॉ ऑफ थर्मोडायनामिक्स. टिल कीप लर्निंग, कीप ग्रोइंग. थैंक यू.